All right, so this is a recording now. I'm going to read it first and then ask you guys. So a researcher conducted a medical study to investigate whether taking a low-dose aspirin reduces the chance of developing colon cancer. As part of the study, 1,000 adult volunteers were randomly assigned to one of two groups. Half of the volunteers were assigned to the experimental group that took a low-dose aspirin each day, and the other half were assigned to a control group that took a placebo each day. At the end of 6 years, 15 of the people who took the low-dose aspirin developed colon cancer, and 26 of the people who took the placebo developed colon cancer. So at the significance level, alpha 05, does the data provide convincing statistical evidence that taking a low-dose aspirin each day would reduce the chance of developing colon cancer? So let's start with thinking what kind of test we're going to run. It does not explicitly say means or proportions or counts. Now, if this was a chi-squared test, we'd probably see a table, okay? So I'm going to eliminate the idea of a chi-squared pretty early because I just don't have enough things to work with, and chi-squared is strictly for categorical variables. So think about, can I make these proportions? You said what? Say that one more time.
I decided Z.
You decided Z test. Okay, why?
I didn't know how to do it. That's how far I got.
Okay, you decided Z test.
No, I thought it was significant.
Okay, so I agree with Z test. But I also want to know, is that going to be a one sample or two? Do we have one or two?
It's one sample, you split it.
So one sample.
So it was, and we're comparing,
So it's 500 and 500.
so we're comparing the two samples from one group. So this is fine to think of this as two proportion Z test.
Why is it a Z test?
Because we can make this 15 out of 500 and 26 out of 500. Those are going to be p hat 1 and p hat 2. So it didn't explicitly say means or averages, which is going to make me think that it's a Z test. So 2 prop Z test. Now, really? Oh, it's not popping up. Oh, am I?
Yeah, I realized. Yeah.
Sorry. I had the screen on frozen, but fortunately that freezes the projector, not the computer. So this screencast should be intact. What are the two populations then? Think about defining. So we're going to be estimating the proportion of people who get colon cancer with the experiment aspirin. Is it aspirin? Yeah. And then the other proportion will be placebo, and it'll just be the proportion of colon cancer with placebo. Or you could also refer to that as the control.
This is defining the variables.
Yeah, this is defining variables. We're at the point that we are being very thorough with everything we do. Proportion of people with colon cancer who develop colon cancer with the experimental aspirin versus the proportion of people who get colon cancer with the placebo. For a 2 sample Z test, we have to say that the groups are random and independent, right? And if they aren't, you're assuming it. 15 and 26 are less than 10% of all potential colon cancer patients. Say that again? Actually, you're right. You called me out on that. That should really be 500. No, you're not wrong. So it was 1,000, but you have to measure it for each sample. Each sample needs to be less than 10%. Okay? So 500 is, well, 500 and 500. Because in the future, you can't guarantee it's an even split. You would say, well, if the first group has 15, well, I guess we're calling colon cancer success. So 15 successes, that means there's 485 failures. You meet there. And then that means the other group, 26 successes, would have 474 failures. So both groups have 10 successes and 10 failures. And we proceed with the two-sample z-test. So, null hypothesis is that the two are what? Think about the null hypothesis when we have two samples. They are independent, but what's the null? We have two. There's an experiment and there's two samples. So the proportion, the proportion from the experimental group or the proportion from the placebo group should be what? Are equal, yeah. Other way to write that. And the alternate in this case, you could say they're not equal, and you can do that, but I think that there's a better answer.
Reduce the chance. So
It says reduce because you're talking about a drug regimen. So potentially they're not going to give people drugs unless they think that it's going to reduce the rate of colon cancer. Yes. Was that a success snap?
Oh, it was not.
All right. So p hat for experiment. There was 15 of the 500, which is about 3% getting colon cancer. The placebo was 26 out of 500, or a little over 5% getting colon cancer. What's one of your favorite, well, which one of those would I use to find the standard error? Can you say it a little louder for the microphone? You have to pool them. Since you have two p-hats, you would have two standard errors. We pool them together. The only reason you make a pooled p-hat is to get a pooled standard error. P-hat that's pooled is add the 15 and 26, and then add the 500 and 500 to get the 1,000. So you'd have 41 over 1,000, or 0.041. And you're using that for your standard error. So 0.041, 1 minus 0.041 is 959. Over 500, over 500. Now, yeah, I recognize those are the same. I'm actually writing it all out because you don't know that these sample sizes are going to be the same in the future. All right, it's back recording again, guys. So we're going to have to use a z-score here, and you're going to find the difference of the two. So 3% colon cancer rate versus about a 5%. We only have 30 seconds, so we're going to have to pick this up on the next one. Over 0.125, which is our standard error. Just to generalize that, it's p-hat 1 minus p-hat 2 over standard error from the pool. That should have been negative 1.76. Now remember, this is a 1 sample. This is close to 2. we're going to really have to find a p-value to determine